Example 4, find all asymptotes of each function. So you really have to go back and look at these rules for determining asymptotes here. We're going to start by finding the vertical asymptote. Vertical asymptotes are where the bottom equals 0. So we have to figure out where the bottom equals 0, and that's usually going to mean factoring. So x squared minus x minus 6. We need to think of two numbers that multiply to 6, negative 6, and add up to negative 3. Negative 3 and positive 2. We just factor the bottom. Okay, if you can factor the bottom, it's pretty easy to tell me where the bottom equals 0. Bottom equals 0 at x equals 3 and x equals negative 2. All right, those are your vertical asymptotes. Now you have to be careful. Okay, and the reason one reason you want to factor everything is because if this had said x plus 2 on the top, then we would have canceled those and it would have been a hole. If it makes 0 and cancels, it's a hole. That does not happen in this case. Those things do not cancel. So just wherever the bottom is 0, that's a vertical asymptote. Move on to horizontal asymptote. In order to do that, you need to look at the degree. See how the degree of the top is 1? And the degree of the bottom is 2. So you compare those. Degree of the top is less than the degree of the bottom, right? Degree of the top is less than the degree of the bottom, so that means we have a horizontal asymptote at y equals 0. Part B, pretty easy to see where the bottom equals 0. Bottom equals 0 at x equals negative 1. Now, you really should probably try to factor the top because it could be the case that something cancels out. If something canceled out, you might be looking at a hole instead of a vertical asymptote, but nothing cancels out in this case. Nothing cancels, so this is a vertical asymptote. Horizontal asymptote. So degree of the top is 1, and bottom is also 1. So you look back at your rules. If the degree of the top equals the degree of the bottom, then we have a horizontal asymptote at the leading coefficient of the top divided by the leading coefficient of the bottom. So the leading coefficient of the top is 4, and the leading coefficient of the bottom is 1, so we're looking at y equals 4. There's a horizontal asymptote at y equals 4. Part C, vertical asymptote. Yeah, it's just y equals 4. Does that answer your question? Okay, vertical asymptote where the bottom equals 0. Bottom equals 0, x equals 1. Now you probably want to factor the top just to make sure nothing cancels. If something canceled, it would be a hole. In this case, it doesn't, so it's a vertical asymptote. Horizontal asymptote. Degree of the top is 2. Degree of the bottom is 1. So the degree of the top equals the degree of the bottom plus 1. So when you look at this and you see the degree of the top equals the degree of the bottom plus 1, you're going to notice that that's not a horizontal, that's oblique. So again, unless you have those rules memorized, you better have them out and looking at them. This is going to be an oblique, and we're going to have to do long division. So I know most of you don't like long division. You can do synthetic if you want, and that's fine. So if I did long division, you divide here and here, you get x, you multiply x times x minus 1, that's x squared minus x. You subtract, which changes the signs, gives me 2x. You'd have to remember that it's a 0, and we bring down this 0. And we start over. We divide 2x by x, and we get plus 2. Multiply 2 times x minus 1, that's 2x minus 2. And when we subtract, we're going to change signs and get a 2. Well, I don't really care about the remainder. All I care about is this part. There's going to be an oblique asymptote at y equals x plus 2. Now let's go through that again and let's do synthetic because I know you'd probably rather. Synthetic division, you've got 1x squared, you've got 1x, and you've got 0 as your constant. And you're going to divide it not by the factor of x minus 1, but by the 0 value of 1. So add straight down as a 1 and multiply as 1. Add straight down as 2 and multiply as 2. Add straight down as 2. Remember, that's your remainder, which I don't care about. That's your constant, and that's your x term. So that's looking like x plus 2. Okay? And that's what we have. There's our oblique asymptote. Graphing a rational function. They take you right through the steps, and steps 1 and 2 are find the asymptotes. Step 3, plug in 0. Step 4, find some intercepts. So you're going to have to factor some stuff. Step 5, we'll have to talk about later when we get into an example. Step 6, you plot the points, meaning make a table. If you need to figure out more points, you plug in more points. And we've already talked about this chart. So even and positive, even and negative. So up, up, and down, down. This is odd and negative. This is odd and positive. When you're graphing, you really want to look back at these steps, but you also want to look back at the asymptote rules. So if you have both of those things out, you ought to be okay. I don't imagine you're going to want to memorize these steps, so make sure you're going to have the steps and the asymptote rules handy. Good luck.